Thanks for joining. Yeah, the title got a little long here. Naming was always the hardest part, right? But I guess the point here is that I guess most of us that have been deploying stuff on Kubernetes has kind of run into this setting where you deploy your application and then you start deploying other stuff around your application because there's these things that you want to solve inside of your cluster, and then you end up running your application, but you also end up running a lot of other pieces and bits in your cluster, and they need to be operated, they need to be managed, you need to keep them up to date, and so on. So basically the idea here is that what if we actually was able to kind of build a platform that supported our applications and have somebody else actually manage and run this platform, either a platform team or an external vendor like Netic. So basically that's what we have been doing, and I'll kind of walk you through the things that we have discovered that we find our customers most often try to solve and maybe inspire you to go look at your own platform, and so that we do not have to build it from scratch every time that we deploy a new application. So just the mandatory slide about myself. As Lasse said, I work with Netic. I have been working with IT around 20 years, I guess, both as developer and architect, and with infrastructure, and a lot of years in the financial industry. And I often find myself kind of in the gap between building the applications and getting them into production. So kind of getting the infrastructure and the applications to meet, and that's basically also what we do with the Kubernetes, right? And do with the platform that we build on top of Kubernetes. Yeah. And that's what I do at Netic now. I've been working with Kubernetes for like 5+ years. I think it was like 1.5 or something, the version when I started working with Kubernetes. So quite some years now. So for the agenda, something like this. First, I'm going to kind of set the stage and what are the kind of issues here, or the challenges that we solve to actually run an application in a production grade setup, and then I'll hopefully, if the demo gods is happy today, I'll do a demonstration on how do we actually onboard an application and go from having no application in our cluster to actually running in something that is a production grade setup, hopefully in 20 minutes or so, and then a short wrap up at the end there. So setting the stage. For start, here we have some code getting developed by some developers, and I guess by now we have a setup with most businesses, I guess, that can build the code and package it as a container. A lot of stuff is going on in the CI area also, but that's not for the talk today. So we're just assuming that the code, one way or another, ends up packaged as a container image that we can deploy, along with some resource manifests that actually describe how we want to deploy it inside of Kubernetes. So the question here is, how do we actually deploy them? And most of us, when we start working with Kubernetes, well, we get acquainted with the kubectl command, right? So the first approach here would be to kubectl apply our manifests and tell the cluster to pull the container image from our image registry, and we're good to go. However, I guess as most of you know, that don't hold up for long, right? Because we are doing this from our local workstation, and we do want to know who is actually deploying, and we probably want an audit trail, maybe separation of duties and all that kind of stuff. So one other way to go would be the CI server approach, right? And we have done that for years in other settings than Kubernetes, where we basically, as part of our CI server, give it some credentials and let the CI server deploy whatever system we have built, right? And that works fine, and possibly for many that's also a viable solution. There are some drawbacks though. One drawback is that we're actually giving the CI server credentials here, right? So the CI server ends up having credentials to all the clusters that we want to deploy into. So now we have a CI server which may not be the most hardened component security-wise within our infrastructure, and it sits on top of credentials for a lot of clusters, maybe even production clusters there. So that might be one issue with that approach. The other issue is that the source of truth as to what is actually deployed inside of our cluster is now scattered across a number of CI builds, right? So we need to go into the CI builds pipeline and see what builds have been done here and have they actually deployed to our cluster. So imagine that we wanted to rebuild such a cluster. Then we have to go in and restart a number of different pipelines in our CI server to actually get the applications redeployed. So one solution to this that is growing more and more popular is using GitOps, where we kind of turn it around, right? So now this is not a talk on GitOps as such, but with GitOps you basically have your source of truth in a Git repository, and then instead of kind of pushing it out to the cluster are more autonomous and pulls in the changes from GitOps and trying to reconcile the state of the cluster into the desired state which you have put into Git. So that is one way to kind of mitigate some of the other stuff there. That may also come with some drawbacks. So one way or another, we need to kind of deploy our application inside of the cluster. And depending on which approach we choose to deploy inside of the cluster, we might need some component to run inside of the cluster. If we choose to do GitOps, well, we need some kind of component inside of the cluster that is actually the GitOps engine that actually pulls in these changes. So already here, starting to deploy our application, we add the first component to our cluster, which is not actually business logic, right? So that's the one up at the top there. Just to illustrate, now we have added something to the cluster handling deployment. The next thing is that we have the application running. We want some kind of ingress into the application, assuming that this might be some kind of web application, right? It could be other kinds of applications, but for the sake of the example here, let's assume that we want HTTPS traffic into our application. Kubernetes actually still do not come with a standard solution for Ingress. You have to make a choice on which Ingress controller do you actually want. So do you want to run Nginx? Do you want to run Contour or Traffic or something else? You need to make a choice there of the Ingress controller. Also, if we want our traffic to be encrypted here, we might also want certificates for doing TLS on top of our HTTP connections, right? So we might want some component that can handle the refresh of certificates and issuing of certificates. And finally, we might also want to be able to do custom domains. We might want the developers to be able to specify which domain name should this application be exposed under. So we might also want some kind of integration into some kind of DNS system. So again, we add some more components to our cluster besides the application here to handle these different kinds of challenges, right? At this point, we actually have an application running and we get Ingress into our cluster. So now the customer calls us and say, hey, my application isn't performing, so what is going on? And I'm getting ahead of us. We take the next one. To get a grip on what's going on, we need some kind of transparency into our cluster. So we need to be able to get observability into what is actually going on. And I'll get back to this, but normally we talk about observability with 3 pillars. We talk about logs, metrics, and traces. So we need to add something that can pick up the logs, maybe something that can pick up metrics from our applications, and maybe something that can pick up traces, right? So again, we add one or more components that needs to be operated, monitored, that need to be kept up to date to ensure that we are not kind of having security vulnerabilities in the components around there. And then the part that I skipped here, because was getting ahead of myself, was secrets handling. Now, assuming that we actually did GitOps for doing the deployments, we probably do not want to store our secrets inside of Git, at least not in clear text. And the standard Kubernetes secret might look encrypted, but it's only base 64 encoded. So it's basically just to be able to handle binary values. It's not an encryption as such. So there's different ways of actually handling the task of getting secrets for instance, credentials for a database or something like that, getting that into the cluster. And it's also something that we need to solve one way or another. There is ways of handling it as part of the GitOps source. There's also ways of giving the secrets a life cycle that is kind of independent of your GitOps setup. Yeah, and then now we have the application running. We might want to be able to give some assurance that we are actually compliant with the different kind of policies. For one here, we probably want to make sure that no containers are running as root, for instance, inside of our cluster. We might also want to make sure that containers drop privileges in the kernel that they are not supposed to use. But we might also have more business-related policies. We might want our applications to be labeled with owning business unit or whatever, that kind of stuff. So we might want some kind of policy engine to help us enforce different policies inside of the cluster. For the security part, something comes with Kubernetes. Previously, we had the pod security policies. Those are being deprecated, but a new admission controller is part of Kubernetes to enforce something called pod security standards instead of that. So you get a little bit from the platform there, but not kind of enforcing more business-related policies. So you might also want a component that can enforce policies in one way or another. So now we have a number of different kind of challenges here that we want to solve. And we might go to the CNCF landscape and take a look here. All the little boxes are different projects solving different challenges inside of Kubernetes cluster. So go and take your pick of which one you want. And then if we are building kind of the platform over and over because we're building a new platform for each project, we might end up doing different choices here, even if they kind of solve somewhat the same problem. So the issue here is basically, can we actually build a platform that is fit for purpose, kind of reusable, and make kind of an opinionated choice of systems or components from the landscape here, right? So let's see if it's actually possible, and let's see how it is from a developer perspective to actually bootstrap a new project into such a platform. And as we go, I'll dwell a little bit upon the choices that we have done to solve these different issues that you just saw. Just a brief introduction. The stack that we have selected consists of different components, and we have chosen to kind of put them into the same grouping as the CNCF landscape has. So there's something about security and compliance. There's Gatekeeper and the Open Policy Agent to enforce policies. There's something about traffic management. So we have an Ingress controller in Contour. We have external DNS. We have Site Manager. I'll get back to that. There's something about continuous deployment. We are using Flux for GitOps. So that's in the continuous deployment group. And then observability and analysis is also kind of a huge issue with such clusters. So there's Prometheus, there's log collection, and there is traces through OpenTelemetry. And basically, the idea here is that if we actually achieve building such a stack that is actually viable, that fit for purpose for most applications, there might be variations, of course, but then we can reuse that stack on top of pretty much any Kubernetes cluster, right? So we can provide the application with kind of the same interface towards the infrastructure, no matter whether we are running on Netic on-premise clusters or whether we are running in Azure or Amazon. So that's another gain from actually trying to standardize on something that we then know as an application developer. This is kind of the interface towards the infrastructure, right? So for the sake of the demo, I've written a very, very, very small Go application that exposes one HTTP endpoint, and basically when you ask it on /hello, it just answers back hello world. This is pretty much the most simple thing you can do with Go and HTTP, I think. The only thing that I have added here is an OpenTelemetry library. So basically I wrap the application in an OpenTelemetry handler to be able to push out metrics and traces so that we can get some transparency into the application. So basically this is the source code for the application. There's a link for GitHub if you want to see it for real later on. So what does it take to onboard or bootstrap this project into a cluster? Well, in Kubernetes we have the notion of a namespace, as you probably know. So basically we want this application to live within its own namespace, kind of to isolate it. And there's a number of things to setting up a namespace. There's a lot more than just doing kubectl create ns, right? Because this namespace we want to be in somewhat production grade, and we would like it to be production grade or close to production grade as early as possible in the development cycle, right? So when we deploy to development, we want to be hit by the same things and not discover security issues when we go into staging, so that we actually adapt our source code as early as possible. So creating the namespace, first of all, we need to set up the GitOps. So what we have opted for is kind of delegating the responsibility for deploying into a namespace to a separate Git repository. So basically, the developer or the customer here gets access to a Git repository that can deploy into the namespace. So anything pushed to that Git repository will basically be reconciled into the new namespace here, and that could either be an Git repository that already exists, or it could be a new Git repository. But we need that as kind of the foundation for doing reconciliation into the namespace. Then we need something about setting up quotas, we need network policies, we need the role actually defining what can be deployed from this GitOps repository, because we do not want anybody to be able to kind of mess with cluster-wide configurations, right? We do not want to be able to mess with cluster role bindings or something like that. We do not want the developers to be able to change network policies. Again, you can kind of, by altering the role here, you can kind of delegate more or less responsibility to the Git repository for this namespace. If you actually want to be able to deploy network policies for this particular namespace, you could extend the role definition for this namespace so that developers are allowed to define network policies, for instance. But the normal kind of separation between operations and development, you would have operations manage the network policies, for instance, right? But that's kind of a agreement that you do. And then you saw the secret stuff. We use external secrets to draw in secrets. There's configuration there. You could be creating databases that are specific for the applications here and set up OpenTelemetry. So there's a lot of stuff here to set up a new namespace. And to make this smooth and easy, we created a small Kubernetes operator. And now, before I actually show what the operator is like, I'll kind of start the demo, because all this setup takes a little bit of time to complete. So let's trigger this, and then I'll show you afterwards what is actually going on here. Let's see, just a moment. Just make sure we're up to date there. Basically, I just add one manifest here, and you will see the resource that is part of this manifest in just a moment. So since the cluster itself is also at a cluster level defined by GitOps. Basically now by doing this change, I can add a new namespace. And I push it to Git, and then to help the reconciliation going, I'll just ask Flux to please reconcile this right away. And then I'll show you what I actually was doing here. We created the namespace operator, and basically what it does is all the bullet points that you saw on the previous slide. It does that in one run. So it creates a new GitHub repository. It creates a new SSH key pair, handing one over to GitHub and keeping one inside of the cluster to be able to do reconciliation. It sets up the quotas and the network policies and so on. But the only thing that I actually put into the cluster right now is the Bootstrap custom resource over there. So basically I just saying I want a new namespace here called Netic GOTO app. And then I say the namespace quotas should be sized medium. And for the new Git repository, I want to reconcile against main and from a path called deploy. So right now, hopefully, we are getting a new repository and setting up the cluster. So let's go take a look whether anything actually happened. So we can start at GitHub. Try to do a refresh there, yeah. So if we look at, yeah, you can see there 39 seconds ago. So actually, we got a new Git repository created. We are on main already now, as you can see, and there's a deploy folder. So already now we're actually starting to reconcile what's in the deployment folder, and this is created based on a GitHub template. So actually, as a developer, you already get some. You kind of inherit some documentation from the template, right? So helping you getting started with the new namespace here. If we take a look inside of the cluster, there we have a new namespace called Netic GOTO app. Its age is 86 seconds. We can do a describe and see that there's actually some quota is created. If we go into the namespace, we can look at the Flux resources in here. So that should be a Git repository pointing to the one that you just saw in GitHub. And also, if we look at customize, we can see that it's actually applying the stuff that it checks out from GitHub. So now we actually set up, and now we can start actually deploying our application. So for the deployment, basically, for the sake of the demonstration here, it's a very, very simple deployment. I just, instead of doing Helm or anything else, I just basically created a Helm deployment resource here, and I'm going to push that into the cluster now and see if we can actually deploy the little hello world service there. First things first, I need to check out our new repository here, right? So I'll do a git clone, and hopefully getting that, and then I can go in here and see that now we actually have this, and I'll just remove the stuff that we got from the template there, and then copy the deployment manifest. So basically now this was what you saw on the slide also, right? So a very simple deployment resource pointing to this simple application. And if I enter this one, I should be able to do an add and say that now we are actually doing the first deployment. And again, I'll just ask Flux to please reconcile right away. It should be this one. So we don't have to wait for that. And basically we should be able to here follow the deployment, and we can see already now it's actually the deployment is there. The odd thing here is that there's actually no ready pods. That's a little bit strange. So let's go into the replica set here to see what's going on. It actually has a desired of 1 but a current of 0. So something seems to be preventing us from actually deploying. So let's do a describe here. And if we look at the events, can see here that hopes we are actually not complying with the security policies. And as I described before, this actually forces us to already here at the development point make the correct setup for the security part. So it's basically complaining that we do not have a security context in place, right? So to tell the container runtime that this pod is never, or the containers of this pod is never going to be allowed running with this kind of privileges, we need to add the security context to the deployment, right? That's standard best practice for security in Kubernetes. So basically we need to say we do not want privilege escalation, so no SU or sudo or anything inside of the container. We want to drop kernel capabilities. We do not ever want to run as root, and then we choose some user UID to be not root. So should a container come in with root, it will be overridden by this UID instead. So we need to add this to actually have the pod created inside of our cluster here to comply with the security policies. And luckily, it's already here. We just need to uncomment it. So, and basically it's the same all over again, right? We do a add and we do a fix. Oh, not that fix. Fix security context. And push this and let's do a reconciliation. And then looking inside of the cluster, there it goes. And we got our pod running, right? So that was for the first part. We got a namespace created, we got our application up and running. Next on, we want to have some kind of ingress into the cluster. And I'll just start this and then show you what's going on afterwards again, because that's also takes a little bit of time to get that rolling. I'll just keep that also, yep. So let's just commit this and I'll show what it actually was. Ingress and false reconciliation. Yeah, so Ingress. Basically, although Kubernetes does not come with a built-in Ingress controller as such, it does come with an Ingress resource. And on its way is also the gateway API specification, which is kind of a more advanced way of controlling your Ingress. So kind of there is a standardization around how do you define Ingress into your workload. And basically I just added this Ingress, and below the Ingress, between the pod and the Ingress, is the service resource, as you probably also know if you work with Kubernetes. So I just added the service and the Ingress on top of that. And that should actually allow for our Ingress controller to accept traffic, right? But the other things that we wanted here was a TLS certificate. So we want to be able to issue Let's Encrypt certificates for our workload here. And we also want to be able to create new DNS entries. So the highlighted stuff here is actually telling, the annotations here is actually telling SAT Manager, which is part of the managed component in this cluster, that I want to issue an Let's Encrypt certificate. And the other part here, the host name there, is actually automatically created inside of the DNS server that is kind of, you could say, connected to this cluster. There's a setup with external DNS, and the moment that the external DNS discovers that a new Ingress resource was created and it is actually beneath a domain, top-level domain that I know something about, then it will go to the DNS server and create a new A record for this one. So in just a moment, we should actually be able to access hello, go to Netic DK, and do it with HTTPS, seeing a Let's Encrypt certificate. So let's see if these things are actually propagated to both Let's Encrypt and the DNS server by now. We can try finding a browser here. So if we say hello.goto.netic.dk/hello, it actually responds with hello world, a little bit small, but it's basically just text that comes back. If we look at the certificate here, we can actually see here that can. No, I can make that bigger, but basically that's Let's Encrypt certificate. And if we look at the issuing date here, it's the 5th of October, 1318. That's just now, hopefully. 2 minutes ago in UTC time. Yeah, and so far so good. Now we got most parts of our application running, and we have Ingress to our application. Next up is the observability and the transparency into what's actually going on. And for as far as logs goes these days, basically if we just log to standard out, back in the days we always learned that we need to have a log framework in place, and we need to make sure that the log files are rotated so that you do not fill up the disk and all that stuff. Running inside of a container, we just log to standard out, and it's pretty easy from the cluster to pick up all the container logs from standard out. So that's kind of a no-brainer. There's no extra work to actually pick up the logs and make those available to the developer, right? But for traces and for metrics, you kind of gotta have some agreement or some interface between the applications and collection points. Metrics these days are pretty much always handled by Prometheus, right? So we need to have a way of telling the infrastructure that, hey, here is a Prometheus metrics endpoint that you gotta scrape and pick up the metrics. For traces, things are kind of converging towards open telemetry, so that you can kind of hand over traces. But again, the application needs to know where to actually push these traces, because for traces it's a push of data out of the application normally. So basically, we allow for an annotation on the application here, so that you can tell, hey, I want an OpenTelemetry sidecar, so that I can hand over traces. And we use Prometheus Operator for the metrics side of things, so you can deploy a service monitor resource and tell the infrastructure that, hey, I have something that I want you to scrape, and then Prometheus Operator will make certain that the configuration of Prometheus is changed to actually pick up the metrics from the application. So that's how the interface or the agreement between the application and the infrastructure is here. And then basically there is an Grafana that is accessible for the guys using this platform. And here I can do, I'm not sure whether I'm still logged on. I'll just make sure that is the case. Basically, it will look like this when you come in. And then there's a lot of core metrics, because in this world, when you are running on a platform like Kubernetes, there's a lot of metrics that you kind of get for free. So you can drill down into the cluster here, and you would be able to actually find the GOTO app namespace, and you'll be able to find how much CPU and how much memory are my application actually utilizing right now. This comes without any action from the application side of things. Well, this is just being picked up by the platform itself. But you are also able to query the logs. For this setup, we have a Humio instance running beneath it. But since it's Grafana here, basically it could be any log collection system that was beneath it. And then here we see one logging. The application is created such that it creates a log entry each time this hello endpoint is called. So here we see the trace ID for that particular session. And again, in Grafana, it's possible to make those kind of active. So we can go from a log here and to the trace. So we can see the trace. And now this application is pretty simple and pretty boring in that respect. So basically, there's only one span as part of this trace. But if the trace has spanned multiple services, of course, you would be able to kind of see it here. And also, you can basically query the metrics from Prometheus also. So that's kind of the the last part of that's kind of the last part of the platform. So basically, I think we managed to show that in just 20 minutes you can actually onboard an application, and of course this application was kind of tailored to fit into the platform, but for this simple kind of application, this would be fit for purpose. Then of course in some settings there would be differences and to support the platforms. So I guess the main takeaway is that there is more to running in Kubernetes than Kube with COTL apply. You probably already knew that. It might make sense in some contexts to actually hand out or have somebody else manage and operate all these components, whether it's an in-house platform team. I actually read an article on the new Stack just yesterday where they actually talk about this setup where you have a platform team inside of your business that are running these kind of components for the cluster, so that you can focus, or the application developers can focus on what actually makes business values and provide new features. But it's always kind of a balance, right? So you got to have enough flexibility to support what developers want, but you also need, for it to make value, you also need to take kind of some responsibility away and some of the management operations away from the developers there, right? And then, yeah, for security, it's always nice to have do a push left so that you discover the security stuff as early as possible, and not when you're on the verge of going into production, you find out that, hey, everything is running as root. We need to kind of rewrite everything. So having that early in the process is always nice. Yep, I think that kinds of completed. Thank you for listening. Hope it was worth your time.